Right, good morning. Let's get straight to it. We're dealing with the February 2022 paper. The last time we were dealing with, was it question 1 or question 2? Oh, sorry, it was the first principles example for cos. Yes. Right, so now let's deal with the integration. February 2022. Now, this is how the questions are given to you. So it says determine, then you got the integral of y dx, and they give you y is equal to. So now, when you are answering the question, this is the question on the question paper. Right, so when you're answering the question, you will not write down y is equal to. So that's a common mistake. You know what you're doing with integration, but you still write down y is equal to. Y goes in this place here. So this y is replaced with whatever you have here. Right, so don't waste your time going and copying down the whole thing as y again. You just go straight, put your integration sign, you are copying this, here you're transferring it here. Right, don't do a double job in the exam, just go straight. The integral of y dx, so that's 7x minus 2x cubed times e to the power x to the power 4 minus 7x squared. Now, dx. So now you can see the integral, this is y, and there's your dx. Right, so now what type of problem is this? What type, is this integration by parts? No. Okay, it's not integration by parts, check. The exponent here, you got x to the power 4, check. Do you have a derivative? There's a power 3 there, is a derivative of power 4. Then you have a power 2 here. Do you have an exact derivative or almost an exact derivative? There's it here, here's your power 1. Can you see that? So this is of the type k, the integral e to the power f of x times f prime x dx. Right, where your exponent is f and f prime is this part here where it's multiplied by f prime, you can see that. So how do you answer this type of question? You can let u equal to f of x. So you have an option of using integration by inspection or use substitution. So now, let u equal to, or let me just, let u equal to, that will be x to the power 4 minus 7x squared. So now we can find du over dx, that will be du over dx, that will be 4x to the power 3 minus 7 times 2, which is 14. Sorry, yeah, that will be 7 times 2, which is 14x. Now, what do? You make dx the subject of the formula, so that will be 4x cubed minus 14x, and now we do our substitution. Alright, so let's substitute. Now, what do you expect to happen when you replace dx? You are expecting the f prime x, that means this derivative, to cancel. All the terms with the variable x must cancel. So if we look at it, now this is a 7, that's a 4, that's a 2 there, that's a 14. It's not going to cancel if I just substitute it like that. So what do? Take out a common factor, exactly. So now this is equal to du all over. So what will that common factor be? It will be 2. So if I take out 2, I'm left with 2x to the power 3 minus 7x. Alright, so now almost there. So we got the 2x to the power 3, but what we have there is positive, and what we have here is negative. Can you see that? Then you got a positive 7x. So it must be the identical in order for it to cancel. So what do? Two options. It's either you manipulate this by taking out negative 1 as a common factor. So if I take out negative 1 as a common factor here, or I can take it out there if I wish to. Okay, it's up to you. But whether you take it out here or take it out there, it's still going to be negative. It's not going to make any difference. Alright, so where would you want to take it out? Maybe you're used to taking it out here. Doesn't make a difference. You take it out here, there. It doesn't make a difference. Let's do it. So what do I mean now? Instead of taking out positive 2, we will take out negative 2 there. So what am I doing now? I'm taking out the negative. So when I take out the negative, that means all the signs will change. So if this is currently a positive, as it stands, when I took out the negative, so it becomes minus 2x to the power 3, and this is a negative, it will become a positive 7x. Okay, now let's do the substitution. So we got our 7x minus 2x cubed, which is, that's my f prime there. So now I got e to the power x to the power 4 minus 7x squared, which is u. Remember, the exponent f of x is u. dx is du divided by minus 2 times minus 2x to the power 3 plus 7x. So now what do you notice? It's a perfect match to cancel. So you can see these two cancel. There and there. What remains? What remains is, you know, anything divided by itself is 1. So basically now you got the 1 over negative 2. That's 1 on the top, negative 2 in the bottom. There's my integral there. Then I have e to the power u du. And then from here, easy. When you integrate e to the power u, it's whether you integrate it or differentiate it, it's e to the power u plus c. You're done. Don't forget to substitute back for u in your final answer. So what is u? U is x to the power 4 minus 7x squared plus c. You're done. Right, so that is it. How do you know that your answer is correct? You use differentiation to check. So you might not have time to check every single thing. It's up to you in the exam. So you check. Let's say y is equal to, you take your answer quickly on the side of your page. That's minus 1 over 2 e to the power x to the power 4 minus 7x squared, and find dy over dx. Differentiate it. So what is the derivative here? It's going to be minus 1 over 2 e to the power x to the power 4 minus 7x squared times the derivative of the exponent, which is 4x to the power 3 minus 7 times 2, which is 14x. Right, now let's look at this, compare it to our question. We're almost there. Let's just multiply the negative 1 over 2 back inside because there's no fraction here. So I got e to the power x to the power 4 minus 7x squared. So if I multiply, I'm going minus 1 over 2 times 4x cubed minus 1 over 2 times minus 14x. So I'm just multiplying the minus 1 over 2 inside. You can see that? So what happens now? That's e to the power x to the power 4 minus 7x squared. So 4 divided by 2 is 2. That's a negative, so that's minus 2x cubed. Negative divided by negative times negative is a positive. 14 divided by 2 is 7. Let's compare. Let's compare here. That's correct. That's correct. So that means your integration is correct now. You see? You test it by using differentiation. Let's deal with the next one. Alright, so our next question, 4.1.2. We got y is equal to 6 all divided by 7 plus x squared. You know, this is the question. In the question paper, you don't copy it as y. You just put your integration sign in straight. So that's integral of y, which is 6 all divided by 7 plus x squared dx. Now, what do we notice about this type of integration problem is that this is a fraction, but the numerator does not have an x there. Why am I saying an x? Because this is x squared. So the derivative of an x squared is x to the power 1. We know it's 2x to the power 1, but you focus on the variable, the power of the variable. So look at the power here. Like here, we looked at the power. This was a 4, this is a 3, it's a derivative. This is a 2, this is a 1, that means it's a derivative, it's just that it's not exact. We had to go and manipulate it by taking out that common factor. Remember that? So there's certain key things you check, only a few seconds it takes to check. Okay, then you'll know what to do. So now here, clearly there's no x here. So this type of integration, exact derivatives, f prime x does not work here. So this involves trigonometric substitution. Okay, so this is trigonometric substitution. Now, it's only 3 marks for in this exam, this 2022 February exam. So this was 3 marks. That means we will not do it by first principles where we do it the long way. But I'm going to do it just now, just for practice. But for this exam, if it's only 3 marks, they did not state you must show trig substitution. That means you go straight to the formula sheets. So you go to the formula sheets. And you're looking for one of those 6 formulas that you are given. 6 under trigonometric substitution. So you are looking for this one. A squared plus x squared dx. Okay. So on the N5 formula sheet, it's given to you as a squared plus the coefficient here must be a 1. And this one is easy because let's see what we can do here. Now, okay, sorry, before I get to that, this is the match. So you know there's no square roots here. There's a plus sign. It's a constant, a number squared plus the variable squared, not the other way. It will work the other way since it's plus. Okay. So this is equal to 1 over a times inverse tan x over a plus c. In the N6 formula sheet, it's given to you as a squared plus b squared x squared. So if I integrate this, it will be 1 over ab times inverse tan bx over a plus c. Right, so that is how it's given in the N6 formula sheet. And this is how it's given on the N5 formula sheet. So the difference is that in N5, you always have to make sure the coefficient of x squared here is positive 1. But in N6, you don't really have to worry. It's much more easier. But unfortunately, this is not N6, this is N5. So we have to do it that way. And it's easy in this case, it's just a positive 1 here. So this is equal to 6 times, we got 1 over. So all you have to do is write it as a number squared. So 7 can be written as square root 7 squared, and then I got my x squared, there's it, dx. So now, my a here is square root 7, x is just x. We go straight 1 over a inverse tan x over a plus c, and you're done. That's your 3 marks. Now that's 6 times 1 over a, which is square root of 7 times inverse tan bx over a, so that's going to be x all divided by square root 7 plus c, and you're done. So if you are not asked to go and show trig substitution, then it's easy. Make sure you choose the correct formula. There are 6. It must be a perfect match. And that's going to be inverse tan x all divided by square root 7 plus c. So that was using the formula sheets. Alright, so what we have done here is just use the formula sheets because there was no specific instruction. So you just write it as perfect squares or complete the square, choose the formula. Now what happens if they ask you maybe for 6 marks? You need to use a trigonometric substitution to get to that answer. You could be asked. Right, but it's unlikely. Most of the time it's just straightforward. 3 marks, use the formula sheet. But what happens if you are asked to show all working from first principles? So let's see how we're going to do that. So we got the integral here of 6 times 1 over square root 7 squared plus x squared dx. Alright, now so this is of the form 1 over a squared plus x squared dx. We know that. Okay, that's from the formula sheet. But then what we did there was we just went and copied down the formula and substituted. Right. But now how is it actually worked out? You actually work this out by using, as you can see here, a tan substitution. So now, what I can do here is, in general, this will be let x equal to a tan theta. If it's on 1 here, basically let 1x equal to a tan theta. So in this case here, I will let x equal to square root 7 tan theta, because my a is square root 7. Okay, now, what's going to happen now? Just like how we used our u substitution, this is now trigonometric substitution. So it's in terms of theta. So what do? I need a replacement. Now I have a replacement for x. So I'm going to replace x with square root 7 tan theta. You know that when you find du over dx, you need to make dx the subject. And you need to get dx in terms of u, normally. Now we need to get dx in terms of this variable here, which is theta. That's all. So let's do that. dx d theta. The derivative of square root 7 tan theta is square root 7 sec squared theta. Right, the derivative of tan is sec squared. Now I can make dx the subject, so it's going to be dx is equal to the square root of 7 sec squared theta d theta. Right, nothing too complicated here. So once we got dx, we are now ready to replace those variables. So therefore, we now have 6 times. Here I got square root 7 squared plus x squared. What is x? X has now a replacement, which is square root 7 tan theta. That's going to be square root 7 tan theta. That is my x. And what is dx? There's my dx here, which is square root 7 sec squared theta d theta. Now, why do we use a tan substitution when there's a plus sign? It's because of the square identity, which you are going to see in a few seconds. So now what's going on here is we got the 6 times square root 7. I got sec squared on the top. Square root 7 squared is 7. The square root of 7 squared again is 7, and tan squared is just tan squared, or tan theta all squared. Now what do we notice here? 7 is common. Can you see that? You must always have a common factor. If you are using trigonometric substitution, you will always have a common factor. If you don't have a common factor here, you made a mistake. You must always have this common factor, so let's take it out. So this is equal to 6 root 7. I got my sec squared, and I'll take out 7 as my common factor. So I'm left with 1 plus tan squared. Now that's the whole reason why we use the tan substitution, is so we can have the square identity 1 plus tan squared. So now I got 6 root 7 all divided by 7. This 7 is in the denominator there, you can see that. Then I have sec squared on the top. And my square identity now, which you have to know because we deal with powers of tan and cot. Obviously you have to know 1 plus tan squared is equal to sec squared, I forgot, sorry, that is d theta, d theta, d theta. So now it's working out nicely, you can see that. Sec squared over sec squared. So that will be 1. That's 6 root 7 over 7. Now, simple. Integrate 1. So when you integrate 1, what do you get? Just theta. Because if this was dx, I'll write down x plus c. If it was du, I'll write down u plus c. So it's theta. It's d theta, so it's going to be theta plus c. We're almost done. We're almost done. Okay, so now, remember when we use our u substitution, what do we do in the final step? We substitute back. That's exactly what we need to do here. So we need to substitute back now. So remember that x was equal to the square root of 7 tan theta. That is the first thing that we've done there, our substitution. So this is where we're going to get our theta from, because there's theta here. Can you see that? So now I've got x divided by square root 7 is equal to tan theta. But I don't want tan theta, I just want theta only. So what do? I take the inverse of both sides. So I'm going to go inverse tan on the left, inverse tan on the right. Why am I taking inverse tan? Because I want the inverse and the tan to cancel each other out. Okay, so I'm only left with theta, and then on the left hand side, inverse tan of x all over square root 7. Okay. So now we have our substitution. So that's going to be 6 root 7 over 7 times our theta is inverse tan x all over square root 7 plus c. Now let's check if our answer is the same. So we got our inverse tan x over root 7, inverse tan x over root 7. The only thing that doesn't match is this is 6 over root 7 and this is 6 root 7 over 7. So this answer here, we just left it as it is. This, the denominator, if we rationalize this denominator, let's see what happens. If you're wondering why these two are not matching. So if I go 6 root 7, if I want to rationalize the denominator, what does that mean? I don't want any square roots in the denominator. What will I do? Multiply by square root 7 over square root 7. So, what is square root 7 over square root 7? It's just 1. So you're not changing the question in any way. So now 6 times root 7 is 6 root 7. Square root 7 times square root 7 is 7. So therefore 6 root 7 is the same as 6 divided by square root 7 is the same as 6 square root 7 divided. It's just written in a different way. This one has a rationalized denominator. This one does not, but it's the same answer. So do not use this. Only if you ask to use the trigonometric substitution, then you will have to do it this way. Otherwise, for 3 marks, straightforward, easy, formula sheet, and you're done. Let's move on to the next question. Okay, our next one, 4.1.3. This is a fraction. This is under integration. So when you see a fraction, the first thing you are checking for, your first check is, does it satisfy this condition? F of x, f prime x, dx, which is equal to ln absolute value of the denominator plus. You always, if you have a fraction, you check, is the numerator an exact derivative of the denominator? If the answer is yes, then you let u equal to the denominator. If the answer is no, then we need to use a different technique to integrate this here. So let's check my denominator. If I call my denominator f of x, is the numerator an exact derivative of x minus 2? Obviously no, the derivative of x is 1. Here we don't have 1, we got 3x cubed plus 4x squared minus 6, definitely not 1 on the top. So that does not work here, the u substitution. Not u substitution, it will not work in one step where the numerator is an exact derivative. Now, what do we do? This is a special case type of example. You could try it by u substitution. It will work. We will do it in a few minutes. But the way that you must recognize to do the technique to use here is long division. Why? Because the numerator is of a higher degree than the denominator. So when do you use long division? Only when the numerator is the highest power on the top compared to the highest power in the bottom. If they are equal, you will use long division. If the top is higher than the bottom, you will use long division. It means that this is now an improper fraction. Because the top is larger than the bottom. So what do we do? Long division. So the denominator is now called the divisor. The numerator is now called the dividend. So that's 3x cubed plus 4x squared plus 0x minus 6. Notice the 0x there. I'm writing it from highest power to lowest power, always. Now you got a 3, you got a 2, you got a 1, x to the power 0. You write it in descending powers, always. So now, long division, we've done it many times. What's the rules? Divide, multiply, subtract, bring down. So we're dividing term 1 on the top divided by term 1 here. So 3x to the power 3 divided by x is going to be 3x squared. Next step is to multiply 3x squared times x, which will be 3x to the power 3. 3x squared times minus 2 is minus 6x squared. That's all. Do we have anything here? No. Write it as a 0. X and write this as a 0. Or if you wanted to, you could have just left it blank. Right, but the fact is there's nothing here, that means there's 0. Okay, so now let's do a subtraction. When we are subtracting top minus bottom for term 1 must always be a 0. It must be a 0 because it's a 3 minus 3. Top minus bottom. 4 minus minus 6. That means 4 plus 6, which is equal to 10x squared. 0 minus 0 is just a 0x here. There's nothing there. 0 is 0. I'm just writing it down so it's in order. Top minus bottom, minus 6 minus 0 is just minus 6. Bring down, since I've written all the zeros here, I don't have to bring down anything. Okay. But otherwise, if I had nothing here, I'll bring down the 0x here, I'll bring down the minus 6, it's the same thing. Now, we go back, step number 1 again, divide. 10x squared divided by x is going to be 10x. Multiply, 10x times x will be 10x squared. 10x times minus 2 is minus 20x. There's nothing here, write down a 0, so you don't have to bring down all the time. You're just subtracting all the time. So if you include your zeros, bring down is unnecessary. Because now I'm filling in this gap here of a 0. Subtract top minus bottom. Remember what I told you, that when you're subtracting sum 1 minus sum 1, you must always get a 0. If you do not get a 0, that means the way the order of what you wrote here is incorrect. 10x squared minus 10x squared, 0. 0 minus minus 20 is plus 20x. Minus 6 minus 0 is just minus 6. Bring down, well, this would have been the bring down, but it's done. Go back again. 20x divided by x, 20. Multiply 20 times x, 20x. 20 times minus 2, minus 40. Subtract. Remember what we're expecting? Sum 1 minus sum 1? 0. We can see that. Or 0x. We just write it as 0. Minus 6 minus minus 40. So that becomes a plus 40 minus 6, which is equal to a positive 34. That's our long division. So now, what do? We need to set up the problem now. Okay, we've got all this information. How do we extract this information and write it down properly in order here? So we need to know what to integrate. So what just happened here? We had 3x to the power 3 plus 4x squared minus 6 divided by x minus 2. How do you set up the problem? Copy down the quotient here, which is 3x squared plus 10x plus 20. Right, so that is the result on the top. And now this part here, you're not dividing anymore now, because there's no more x here now. Can you see that? So this is the remainder. So it's going to be plus the remainder all over the original denominator there, the divisor, which is x minus 2. So the job to do is this part here. The integration is going to be simple now. Alright, so now we're going to integrate 3x cubed plus 4x squared minus 6 all divided by x minus 2. So I need to integrate 3x squared plus 10x plus 20 with respect to x, plus I need to integrate the fraction here. Can you see that? The fraction is 34 all divided by x minus 2. Now, this fraction matches this standard form. Can you see that? You must be able to notice that this is f prime. The 34, obviously you're going to write the 34 in front. You should know now. And this is simple integration. So let's do this. So this is going to equal to 3x to the power 3 over 3 plus 10x squared over 2 plus 20x plus 34 times 1 over x minus 2, which is going to be ln absolute value of x minus 2 plus c. And you're done. So that make sure you know your long division. You can see that. So 3 and 3 will cancel. You end up with x cubed 10 divided by 2. That's 5x squared plus 20x plus 34 ln absolute value x minus 2 plus c, and we're done. So that was the long division method.